Hello everyone, I am Yashwant Kumar, pursuing Bachelor of Technology in Weltech University, and our project title is Bitcoin Price Forecasting Using Deep Learning Techniques. And my team members are Praveen Kumar Reddy and Varunad Reddy, and supervisor is Vinodini Ma'am, Assistant Professor, CSC Department. Coming to the abstract, cryptocurrencies are decentralized currencies and provides global acceptance and easy exchange. And it has high security and financial growth to invest. These are attracted the investors to invest their money in the cryptocurrencies. Mainly, forecasting and predictions of the prices plays an important role in the financial industry, and many statistical computational techniques are used to overcome the problem. Here, to identify the most efficient algorithm for predicting the Bitcoin price, we are using the root mean square error and absolute mean errors for deep learning algorithms. Coming to the objectives, the main aim of our project is to prediction of price of Bitcoin by using the deep learning techniques. And we are using some statistical methods which are mean square error and absolute error for predicting the best algorithm for of Bitcoin price is validated. And scope of a project is to forecast and give a precise or by providing the complete view of Bitcoin behavior during one day in the future, creating the powerful tool for the investors could use the short-term trade of a Bitcoin without any hesitation or doubt. Okay, and hence forecasting the Bitcoin price having the have attached the attention of many researchers in the field of several statistical methods. And here we are using the deep learning algorithms to predict the Bitcoin price and provides the prices in a minute granular time of the entire next day. And we are using the three main algorithms in this project. The first one is LSTM, which is long-term short memory, which is most popular, and it is also a recurrent neural network algorithm used in deep learning. And it can be processed as single data points like images and entire sequence of data like a video. And it has three gates. Those are input gate, output gate, and the forget gate. It can also use it for the classifying and processing and making the predictions. Next, we'll go to the GRU. GRU is nothing but gated recurrent unit. Is a type of recurrent neural network which is same as like LSTM, and it has two gates: updated gate and reset gate. Coming to the MLSTM, which is nothing but multiplicative LSTM, is also a type of recurrent neural network architecture for the sequential modeling that contains the both LSTM and GRU. So combination of both LSTM and GRU, which on providing the more efficient possible output in the MLSTM. These are the literature review, and here we have gone through with 4 to 5 papers, and we have get to know what is what in the papers which are already published through the past years, and we get to know more information about that, and we have concluded, we have modified the present algorithm. And coming to the design and methodologies, and here we have some modules. At module 1, first we have the collected the data, and we have given the training using deep learning algorithms. And module 2, we have identified the mean square error and absolute error using the best algorithm for predicting of Bitcoin prices is validated. And module 1 is, this is the collecting of data, and step 2 is a processing of data, and the step 3 is we are applying the deep learning algorithms. And after applying the deep learning algorithms, we will get the some output, which is nothing but see here, it is the graph plotted the graph. And coming to the implementation, here we have given the architecture diagram, data flow diagram, and sequential diagram. Architecture diagram in the sense, first we have to give the training data sets. With that, it generates the multiple time series which we have to train the data sets multiple times so that we can get the correct output. It means accuracy output we'll get after training more and more times. After testing the data, it generates the multiple time series, and with that, we will get to know the best model after prediction. Next is data flow diagram. Here also same, like first we have to give the data, and and we have to pre-process the data, and we have to give the attribute selections, and after giving the attribute selection, we have to give the learning algorithm, and we have to train the data, and we have to test the data and make the predictions, and get the evaluate results. If the results are not good, not accuracy, and again the same process will continue up to getting the correct accuracy. And the sequential diagram is also the same, like training the data and giving the algorithm, if I'm predicting the correct output. If not, again the process will be continuous, vice versa. Okay, at last conclusion, deep learning models are compared, and the data sets are stimulated based on the data sets, and mean square error and absolute error are the best algorithms for predicting the Bitcoin price is validated. The most efficient algorithm for the Bitcoin price prediction is validated. And offer letter is the industry details reference. Thank you.
Hello everyone, I am Ishwant Kumar and pursuing Bachelor of Technology in Weltech University, and my project title is Bitcoin Price Forecasting Using Deep Learning Techniques. And my team members are Praveen Kumar Reddy and Varunad Reddy, and my supervisor is Vinodini Ma'am, Assistant Professor, CSC Department. Coming to the implementation of our project, here we are predicting the most efficient algorithm for Bitcoin price, and we are using the two different types of algorithms, which are nothing but LSTM and GRU. LSTM in the sense long short-term memory. For long short-term memory, first we have to import the required modules, which are nothing but NumPy, which is used for the numerical computation, and next import the pandas for used in CSV files. CSV files in the sense comma separated values. Here we are giving the CSV file which have respected date and the price of the particular date. And next we are importing the matplotlib, which is used to represent the data in the pictorial graphical representation. And we are importing the keras for importing the algorithms, which are nothing but LSTM, dense and sequential. And at last we are importing the sklearn, which for min max scalar, which is used to convert the values from 0 to 1 range. After that, we have to read the CSV files. CSV file in the sense comma separated values, which is market price that CSV file have to read. And next we have to read the head file, which is nothing but first starting 5 values of the file, and next tile is nothing but last 5 values of CSV file. And then we have to do the pre-processing, which is nothing but the main aim of our project is predicting the next 30 days of price, future price. And we have to train the data by using the train method, which is nothing but length of the particular data set minus predicted days, last 30 days, and also test the data. After that, after completion of the training, we have two functions, which is nothing but activation function and the optimizer. Activation function is sigmoid function and optimizer is Adam. And we have the loss function is mean square error. And here we are giving the number of epochs 400, will train the 400 times, and adding the input layers as number of units and the activation function, and getting the output in the units. And at last, after completing the training, it will test the data and generating the graphical representation of a particular predicting values. The red color represents the actual Bitcoin price, and the blue color represents the predicted Bitcoin price. And when we see here, the distance between the red color line and blue color line is very small. So our predicted values is accurate, most probably it is accurate. And after that, we have to find the error rate. Here we are finding the mean square error and absolute mean square error. So after testing these two errors, we have got some values. The values are more similar, very less. So at last, we are predicting the last 30 days, next 30 days of our Bitcoin price. This is the LSTM. Then go to the GRU, the same as LSTM. Here we are importing the NumPy, Pandas, and Matplotlib and Keras modules. And after that, we have to read the CSV file, same as market.csv. And we have to pre-post the data by using the 30 days of future 30 days. And we have to train the data and test the data. And we are giving the activation function as sigmoid, and the optimizer is Adam, and loss function is mean square error. And after that, we have to use the sklearn pre-processing for standard scaler for converting the values from 0 to 1 range. And after that, we are giving the input layers, which has activation functions and number of inputs for getting the output. And we have to give the number of epochs as 400. It will train the 400 times and giving the accurate value of particular values. And when coming to the graphical representation, see here, yeah, that same as like that, red color represents the real Bitcoin price and the blue color represents the predicted Bitcoin price. When compared to the LSTM, the GRU has very less distance between the real and predicting values. So after that, we have to find the root mean square value and mean absolute value. The values when compared to the LSTM, GRU error rate is very low. So that at last we have concluded that GRU is the best algorithm for predicting the Bitcoin price.